Hey guys, welcome again to the Maths Club. If you're just joining us, welcome. In this video, we're going to be looking at surface areas, volume and perimeter of cubes, cuboids and cylinder. Prior to this, we're looking at areas and volumes and perimeter of 2D objects, but in this place, looking at 3D objects, and that's what we're talking about, surface area. So if you have not subscribed to our channel or liked our video or commented before, this is a good time to actually start. Let's get started. A solid is actually a three-dimensional shape. So any solid you see in the world, maybe your food flask, your biro, your school notes, your cup, they are all solids. And if you take your cup, so all of the area around it, you see that circular area, that is what they call curved surface area. The bottom, right? The handle, all those places, by the time you add up the area of all those places, you have total surface area. So it says that the surface area symbolized by A of a solid object is a measure of the total area that the surface of the object occupies. So by the time you add all of those areas, you would have the surface area. And of course, because it's an area, it is measured in square units. We've made a mention of this before, that for two-dimensional shapes, the area is calculated, and for three-dimensional shapes, total surface area is calculated. And we have come to the place of three-dimensional shapes. So let's see one of them. The first one we're going to be looking at is a cube. And the cube is a solid with 6 faces of equal dimension. So if you have this sugar brand, maybe Golden Penny or St. Louis Sugar, the cube. If you take a cube of it, you see that each of all those faces have equal dimensions, like a square, 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 square all around. And there are 6 faces there. Right, so that cube is a solid with 6 faces of equal dimension. So this is an example. So you can see each of those lengths, this length here, this length here, this length here, this length here, they're all going to be of length A. Because of this, we can find the surface area. So we said each of them are of 6 faces with equal dimension. So I need to find the area of one of the faces. So the area of, let's say, this face here, if this place is A, this place is A, area of a cube is A squared, right? So that means one face has an area of A squared. And we said there are 6 faces. This guy, this guy, this guy, this guy, the front, and then the back that is just behind this guy. So there are 6 faces. So that means the surface area is going to be 6A squared because there are 6 faces. And then for the perimeter, see, if you count each of these lines, this 1, this 2, this 3, this 4, right? This 5, this 6, this 7, this 8, this 9, this 10, this 11, this 12. So there are 12 different lines. That's why the perimeter is going to be 12 times A, the length of one of them. Makes sense, right? Great. For the volume, volume is always taken as base area times height. So for the base area, we said the base is a square, yeah? And that will be A squared multiplied by how high is the cube. The height is also A. What do I mean? So just like as if you have a square at the bottom and keep on stacking squares, 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 squares on it. Right? So how many squares are you going to put, or how high is that your square stack? That will be your A. Really, what you just have here is a square, and then you're stacking multiple squares on it. It's a layer of square, it's a layer of square, it's a layer of square. So how high is that layer? Right. So A squared times A will give you A cube. And that's where we have the volume formula from. A cuboid is a shape with a rectangular base and sides. So unlike a cube, which has a square base, this one has a rectangular base. So we can see the rectangular base here, we can see the length, and we can see the breadth. So, if you were to find the surface area of this guy, you see, you have to take note of this front, the back, the left, the right, the top, and the bottom. So for this guy here, the area is going to be H times B. But also that H times B also be the same area of the other guy opposite it. So by the time you add those two areas as well, you have 2BH. For this guy here, when you find the area, this is the length and this is the height. So you multiply length times height. And also the guy that will be opposite it will also be length times height. So by the time you add two of them together, that will give you 2 height times length. And finally, for the top, right, this is the length and this is the breadth. The area of this guy is length times b, which also be the area of this guy, L times b. So by the time you add those two areas, you have 2lb. And of course, for the perimeter, is that this is 4l plus b plus h. See, so for this b, you have how many of them? You have 1, 2, 3, 4. For the h, you have how many of them? 1, 2, 3, 4. For the l, you have how many of them? 1, 2, 3, 4. So by the time you add all those guys, right, you have the perimeter. And of course, the volume is the base area times height. So if you look at this guy, the base area for this guy, this is the base, is L times B times how higher you stacking those rectangles on each other. How higher they? So this is H. So times H. And that's why we have LBH. As a process that we should calculate the total surface area of a cupboard, which measures 12 cm by 10 cm by 8 cm. Let's take from WAEC 2004. Let's solve it. So in this question, we are given that the length is 12 cm, the breadth is 10 cm, the height is 8 cm. So the total surface area, like we said, will just be 2lb plus 2bh plus 2lh. So our lb is 12 times 10, which is 120 centimeter squared. Our bh is 10 times 8, which is 80 centimeter squared. And then our LH is 12 times 8, which is 96 centimeters squared. So if I substitute, our total surface area will just be 2 times 120 plus 2 times 80 plus 2 times 96. And that will be equal to 240 plus 160 plus 192. So let's add 240 plus 160 plus 192. That will give you 592 centimeters squared. And that will be option B. Great. Example 2 says that the volume of a box of height 8 cm is 320 cm cube. What is the volume of a similar box of height 6 cm? That's from NECO 2003. As always, I expect that you're pausing these videos and trying to yourself before you look at my solution. So we have a box 1, we have a box 2. They have similar, when you say the height is 8, the height is 6, and then there's sometimes that they have a similar base, right? So whatever is the base area here, which will be LB, will also be the base area here, which will also be LB. The height of this box 1 is 8 centimeter, and then the volume is 320 centimeter cube. The height of this guy here is 6 centimeter. Then I want to find the volume of this guy. So from here, I know that my volume of, this is basically a cuboid, is LBH. LB is the same here, LB is the same, so we can just say the volume here is 320 is equal to LB times 8, and divide both sides by 8. Our LB will be equal to 40 centimeter squared. Now that we know this, we can find the volume here. So the volume of this guy will also be LBH. We know our LB from this guy to be 40, so that will be 40 times 6, and that will be 240 centimeter cube. That will be option B. Great. Example 3 says that the cube and cuboid have the same base area. The volume of the cube is 64 centimeter cube, while that of the cuboid is 80 centimeter cube. Find the height of the cube. This is from NECO 2003. As always, I assume that you've already paused the video. So we have a cube and a cuboid. The base area of a cube, so let me just say cube and cuboid. Then for the cuboid, we have this. They have the same base area, so that would be LB. Would be same as saying LB. Of course, a cube is really a square, right? In all the sides, they're all square. So the LB here would also be equal to, let's say, L squared, right? The volume of the cube is 64 centimeter cube, while the volume of the cuboid is 80 centimeter cube. So we're trying to find the height of the cuboid. For a cube, we know that the volume is going to be what? L cube. So that will be 64 is equal to L cube. And if I take the cube roots of both sides, my L will just be equal to 4 centimeter. So that means that the base area, which is L squared, will just be 4 squared, which will be equal to 16 centimeter squared. And you know they said that they share the same base area, right? So that means that the LB here, you can just say therefore LB will be equal to 16 centimeter squared. So we know that the volume is equal to LBH. We're given the volume to be 80, so that will be 80 is equal to LB is 16 times H, and if I divide both sides by 16, my H would just be 5 centimeter, and that's option C. Great. The next shape we're looking at is a cylinder. A cylinder is basically a solid with a circular cross section. If you look at the cylinder, like your tin of milk, tin of Milo, you basically see a circular cross section, right? If you look at the top or the bottom or even the sides, you see that everything is trying to form a circle. So initially you have a circle at the bottom, you have another circle, and that 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 circle. It's this bottom here is the diameter, and this guy is like the height of the cylinder. So we have two types of cylinders, namely an open top cylinder and a closed top cylinder. So when you want to take milk from your tin of milk, right, ideally the top is closed, right? So that's where you have the closed end cylinder. So when you now remove the top to now scoop the milk out, you have an open top cylinder. By that time the top is no longer covered. So you see an example of an open cylinder top, and you can see an example of a closed cylinder top. And of course, in your tin of milk, the bottom is always closed. So you can see this diagrammatic representation. Take a minute and look at it. This is for a closed end cylinder. So you have the top, you have the bottom. See the way it's stretching out. The area of the top, surface area of the top is pi r square, and the area of the bottom is also pi r square. Now for the circular cross section, you can see that the circle round, the length around it is the circumference of a circle, which is 2 pi r, and this is the height. So we have 2 pi r circle, and this is the height, because we need to find the cross-sectional area of this curve, so that the circumference of the circle is 2 pi r or pi d, and this is the height. So by the time it now stretches out, you can see it forms a rectangle. So that means the surface area of this guy here is 2 pi r each. So if we're looking for one that did not have an open top, what we'll have will be 2 pi r each, which will be from this guy, 2 pi r each plus pi r square. But if it now has a closed top, we have to add the top pi r square. That's just the difference. So we said among the three properties of a cylinder, curved surface area, total surface area, and volume, we have curved surface area, which is that curve, right, that stretches out to become a rectangle. Total surface area, which is like the sum of all the areas, the curved surface area plus the area at the bottom and the top if necessary, and the volume. Only total surface area has a different formula for the two types of cylinders, and you can already guess why. So the curved surface area, we've said that is the base area times height. You know, when it stretches to that rectangle, we have 2 pi r times h, and of course it's in square units. And the volume is the base area, which is a circle, pi r square, times how high is that circle going to span, how many stacks of circles do we have on it, which is like the height. So that will be pi r square, h in cubic units. For the top surface area formula, we have for the open top cylinder only, where you've already removed the cover, right? So I mean, in this case, you only have the area of the base plus the curved surface area. So that will be pi r square plus 2 pi r each. Of course, I can factor out pi r. I hope you're painting pictures of these things in your head as we're talking about it. So if I factor pi r from this will give me r. If I factor out pi r from this will give me 2h. For a closed top cylinder, so you have three places: the area of the circular base, the curved surface area, and the area of that top. So that's why we have pi r square plus 2 pi r h plus pi r square. Pi r square plus pi r square will give you 2 pi r square plus 2 pi r h, and if you factor out 2 pi r from it, 2 pi r square divided by 2 pi r will give you r, and 2 pi r h divided by 2 pi r will give you h. So this is how we actually solve it. Example 4 says that a cylindrical well of radius 1 meter is dug out to a depth of 8 meters. So those would have wells at the back of their house, right? So now says calculate in meter cube the volume of the soil dug out, and the soil that is dug out is just to raise the level of the rectangular floor of a room 4 by 12 meters. Calculate and correct to the nearest centimeter. Wow, so we're dealing with meter here, about 8 centimeters. So you have to be very careful. Sometimes they might give you radius of 1 meter, depth of 8 centimeter or 800 centimeter. You have to know how to calculate and work with only 1 unit. So just calculate correct to the nearest centimeter the thickness of the new layer of soil. Take pi to be 22/7. This thing from 1,000. So if a cylindrical well is dug out, so we have the cylinder like this, something like this. The radius is 1 meter, so that's from here to here is 1 meter, half of it, and the height is 8 meters. So we want to find the volume of the soil dug out. I mean, if a cylindrical well, that means they've removed, or I mean, if this was the ground, they've removed this amount of soil from it in the shape of a cylinder. So the volume of that soil, we can just use the volume of a cylinder, which will be pi r square h, and this 22/7 times 1 squared times 8. So 22 times 8 divided by 7, this will give you 25.143 centimeter cube. So we have that. When I told that we have a rectangular floor somewhere, let's say this is rectangular floor, we now want to raise the level of the rectangular floor. We want to raise it, right? So we want to raise it like this, right? We want to raise it, but we want to raise it with the soil that we have gotten. So this guy here is normally 12 meters and this guy is 4 meters, right? But we want to now raise it with this soil, right? I mean, since only this soil we're going to raise, you're agreeing with about pouring the entire volume of this soil on this guy, right? We're pouring the entire volume of this soil on this guy, so that will be the new volume of the floor. So the volume of the floor, which will be LBH, you know, this is how you find thickness. Thickness is basically the height. So that volume of the soil, which is 25.143, is equal to 12 times 4 times h. So that will be 25.143 is equal to 48h. So if I say 25.143 divided by 48, my h is 0.524 meters. But it's said to the nearest centimeter. We know that 100 centimeter makes 1 meter, right? So how many centimeter would make 0.524 meters? So we have to cross multiply. X times 1 will give me x, that is equal to 100 times 0.524. So what would that give me? So this will give me 52.4 centimeter, and it says to the nearest centimeter. So this is basically approximately 52 centimeter to the nearest centimeter. So this is how we actually solve this question. Let's see if we're correct. Great. So 25.14 meter cube and 52 centimeter to the nearest centimeter. Example 5 now says that what is the volume of a solid cylinder of diameter 7 centimeter and height 7 centimeter? Take pi to 20/7. I'm sure this is something you can solve. So we're given this question. The volume of a cylinder will always be the same whether it's open top or closed top. So we know the volume to be pi r square h. We're told that the diameter, which is 2r, is 7. So that means our r is 7/2, and then our height is 7. So this 7/2 centimeter and 7 centimeter. Then our pi is 22/7. So if I substitute, that would be v will be equal to 22/7 times 7/2 all squared times 7. So this 22/7 times 49/4 times 7. 7 cancel 7. 2 here 11. 2 here 2. So 11 times 49 divided by 2. That will give you 269.5 centimeter cube, and that is option C. Great. Example 6 now says that a cylindrical container closed at both ends has a radius of 7 cm and a height of 5 cm. Find the total surface area of the container and what is the volume of the container. Take pi times 20/70 from WAEC 1995. I've assumed that you've paused the video and tried that yourself. So we're told that the radius is 7 cm, height is 5 cm. What is the total surface area and what is the volume? If pi is 22/7. So that the total surface area of a closed cylinder at both ends, we have the top and the bottom, so that will be 2 pi r squared, plus we have the curved surface area, which will be 2 pi r h. And if I factor out 2 pi from this or 2 pi r from this will be r plus h. So this will be 2 times 22/7 times r is 7, then 7 plus 5. So 7 cancel 7. 2 times 22, that is 44, times 7 plus 5, that's 12. So 44 times 12 would give you 528. So this is 528 centimeters squared. The volume of this cylinder is pi r square h, which is 22/7 times 7 squared times 5. 7 comes from the 7, so that is 22 times 7 times 5. That will give you 770 centimeter cube. So this is the solution to this question. Great. Example 7 now says that a tin has radius 3 cm and height 6 cm. Find the total surface area of the tin and the volume in liters that will fill the tin to capacity. Correct to 2 decimal places. Take pi to 22/7. This case, you're not told if it's a closed or an open end cylinder, but we are told to find total surface area, so that matters. If you're not told, assume that it is closed. So if I were to solve this, my radius is 3 cm, my height is 6 cm. Total surface area would just be 2 pi r squared, top and bottom, plus 2 pi r each, which is the curved surface area. So if I factor out 2 pi r, this will be r plus h, and this will be 2 times 22/7 times 3 times 3 plus 6. So 2 times 22 times 3 divided by 7 would give me 132/7 times 3 plus 6 will give me 9. So 132 times 9 divided by 7 will give me 169.71 centimeter squared. So it says to do this. Let's assume that we correct everything. So this in 2 decimal places, which is fine. So I could just say approximately this guy to 2 decimal places, and then for the volume, right? Volume is pi r square h, which is 22/7 times 3 squared times 6. So 22 divided by 7 times 3 squared, which is 9. Then multiply by 6. This will give you 169.71 centimeter cube. You are correct, but the question says that in liters. So in that 1000 centimeter cube is 1 liter. If you don't know it, now you know. So 169.71 centimeter cube will be x liters, right? So let's cross multiply. That will be 1000 times x is equal to 169.71. This times 1. So if I divide both sides by 1000 and divide this side by 1000. So 169.71 divided by 1000. So by the time we divide this, you have 0.16971 liters. And this will be approximately, so my volume is approximately into 2 decimal places, right? This is 7. Okay, this is 9, which is more than 5. So by the time we carry over, this will be 0.17 liters to 2 decimal places. So this is our answer. Let's see if we're correct. Great. Example 8 now says that water flows from a tap into a cylindrical container at the rate of 5 pi centimeter cube per second. If the radius of the container is 3 centimeters, calculate the level of water in the container at the end of 9 seconds. This take from WAEC 1999. First thing that we know is that the rate is centimeter cube per second, so that is volume over time, right? The rate is given to be 5 pi centimeter cube per second. Radius of the cylinder is 3 centimeters, and then calculate the level of water in the container, which is basically the height at the end of t is 9 seconds. Does that make sense? It's dripping inside the distance. So how high has the water risen at the end of 9 seconds? So if the rate is 5 pi centimeters, so I mean if the rate is 5 pi centimeter cube per second, so after 9 seconds would have 5 pi times 9, right? If it's 5 pi centimeter cube per second, so I have 5 pi times 9, which will give me 45 pi centimeter cube, right? So this is the volume after 9 seconds. Great. So for a cylinder, we know that the volume is pi r square h. So this 45 pi is equal to pi times 3 squared times h. If I divide both sides by 9 pi, 3 squared is 9, so 9 pi. 9 will cancel 9, pi will cancel pi, pi will cancel pi, 9 will cancel 45, which will give me 5. So my h here is 5 centimeters. So this is how high the water has risen after 9 seconds. And that is option B. Great. Example 9 says that calculate the surface area of a hollow cylinder which is closed at one end if the base radius is 3.5 centimeter and the height is 8 centimeter, and take pi to 22/7. This is from WAEC 1989. So for a cylinder, if it's closed at one end, we know what to do. The base radius is 3.5 centimeter, the height is 8 centimeter, the pi is 22/7. I mean, with a theory question, you always want to state the given, right? Then state the formula. So for a closed one, I know that the surface area would just be the area of the bottom, which is pi r square, plus the curved surface area, which is 2 pi r h. We're not adding the top because I mean it's not closed at the top, it's only closed at one end. So if I factor out pi r, this would be r plus 2h. And if I substitute that, 22/7 times 3.5 times 3.5 plus 2 times 8. So this is 22 times 3.5 divided by 7. This is 11. Multiplying 3.5 plus 16. So this is 11 times 19.5. So times 19.5. This will give me 214.5 centimeters squared, and that is option D. Great. This leads us to the last concept under this, which is hallowed cylinder, pipes, and rings. So this is a special type of cylinder which is open at both ends, but it has a very thick layer. So it's open at both ends, but has a thick layer. A good example of it is a pipe, right? So imagine the pipe that is very thick. When I mean thick, I mean that this place here, the height here, the distance between this guy here and this guy here is very large, something like this. You can see that is very large. So we have two circles there. We have this outer circle with radius r, and we have the smaller circle with radius small letter r, and this is the length of the pipe. So for the area, remember this, all this side, this inside here, all this inside here is free, right? In the pipe, this inside here is free now. So if we want to find the area, this free side is not covered by the solid, it's open. So we need to find a way to remove this side from it. So that's why we said the area of the big circle, which is pi r squared, minus the area of the small circle, which is small pi r squared, right? By the time you remove the small area from the big area, you have the real area of the hallowed cylinder. So for the volume of this guy now, just like I said, we have this full guy. You assume that, oh, the volume will be everything inside there. No, but there's still this free space too, just like for the area, there's still this free space. So we need to remove this free space from it. So the total area of this guy, this is the base area, which is pi r squared, times the height, which is L, minus, you have to take out this small guy so that you know the true volume of this cylinder. So minus pi r squared L, but this r here is the small letter r. So by the time you subtract this volume from the bigger volume, you would have the volume of the hollow cylinder, right? So if I factor out pi L, this will be r squared minus r squared, one of them being small. Example 10 now states that a cylindrical pipe is 28 meters long. Its internal radius is 3.5 centimeter and external radius is 5 centimeter. Calculate the volume in centimeter cube of metal used in making the pipe and the volume of water in liters that the pipe can hold when full. Correct to 1 decimal place. Take pi to 22/7. This is from WAEC 1999. So we're told that the length is 28 meters, but if these meters, this is centimeters, so we have to convert it to centimeters. That will be 28 times 100, which will be 2,800 centimeters. That's the length. The internal radius r is 3.5 centimeter. External radius big R is 5 centimeter. The volume in centimeter cube of metal used in making the pipe, we've already said before that volume will be pi r square, capital letter r square h minus pi r square h, right? We've talked about that before. So if I thought pi h, that would be r squared minus r squared, and this would be 22/7 times, we'll be given the h, which is the L, yes, so 2,800 times 5 squared minus 3.5 squared. 7 year 1, 7 year 400, right? So 400 times 22, that will give me 8800, and this 25 minus 12.25. So 25 minus the answer, this will give me 8,800 times 12.75. So multiplying this by 8,800, this gave me 112,200 centimeter cube. So this is the volume of the metal used in making the pipe. So the volume of water that the pipe can hold, of course, to be, so if this is the big one and this is the small one, the only place that the water can enter is in this place here, which is the smaller one, right? So that's basically just saying finding pi r square h, basically, because that is only the, I mean, it's in this hollow place that the pipe can hold water. It can't hold water in these solid parts. No, I know it goes all the way down like this. So when it is full, that will be the entire distance. So the volume would be pi r square h, to be 22/7 times 3.5 squared times 2,800. So this 22 divided by 7 times 3.5 squared times 2,800. This gave me 107,800 centimeter. So if I finish solving the question, always go back and see if you took this volume in centimeter cube. Yes, volume of water in liters. So we've not done that. If you leave it like this, you will not get a full answer. So we say if 1,000 centimeter cube makes 1 liter, then 107,800 centimeter cube will make x liters. So if I cross multiply, that will be 1,000 x is equal to 107,800. If I divide by 1,000, this 2 cancel this 2, this will cancel this, so our x would be 107.8 liters, right? And it said to 1 decimal place, so this is correct, 107.8 liters. Let's see if the answer is correct. Great. So with this, we've come to the end of this particular topic. I hope you found it useful. Please like, subscribe, tell somebody about the channel, right? And I'll see you guys in the next video. Bye for now.